And today I want to talk about the challenges and strategies for securing the dynamic environment of a cloud-native enterprise. A cloud-native enterprise is a distributed enterprise, one that rapidly delivers secure cloud-native applications and data across core, cloud, and edge for the best operational and competitive advantage. And the technologies and processes that have enabled this agility are great for the enterprise. But the challenge is that they're also great for opening new doors to harmful bugs that enable malicious attackers. So, once protecting the traditional enterprise was straightforward. Physical security, traditional networking and firewalls, and a reasonable identity management strategy kind of got you there. But then as the cloud began to open the infrastructure and applications beyond the tightly controlled data center. And now that is evolving into a global shift as digital transformation continues to gain momentum. Effectively, every enterprise is becoming a distributed enterprise, able to intelligently place applications and data across core, cloud, and edge to deliver an always-on experience digital business demands. Making this shift is quite complex for IT organizations. You're expected to deploy, scale, and secure a distributed architecture that interoperates seamlessly across hybrid, state, and exploding number of edge use cases. And you have to build, modernize, or migrate applications to a cloud and cloud-native platforms without disrupting, your critical business applications, all amidst an extreme industry talent shortage. The traditional defenses are still absolutely required. Perimeter and identity attacks continue, as evident in recent Google and Microsoft attacks. However, the new infrastructure models, rapid application delivery models, and in the wild distributed ecosystems have greatly expanded the attack surface, and threat actors have become much more creative and aggressive in exploiting vulnerabilities in this vast and rapidly evolving ecosystem. Some recent examples include Havana Crypt, the NitroCod malware attack, SolarWinds with the supply chain exploits that many people encountered, and then most recently of all, and the one that affected everybody, is really the Log4j exploit. So as you're all experiencing, cloud native technologies are really becoming the norm. More and more Kubernetes and container environments are going into production, not just in sandbox or test and dev environments, but real environments where there's sensitive data to protect. And there are PCI compliance and other types of compliance that needs to be ensured. And as applications are being deployed using continuous delivery methodologies, introducing ecosystem challenges on a daily basis. Also in containerized Kubernetes cloud environments, the traditional security tools that you're used to deploying, whether it's the firewalls, intrusion detection, intrusion prevention devices, malware scanning, any of these are really incomplete or just don't work relative to the needs of the business. They're not going to provide you the visibility and protection that you need to protect a cloud-native environment. And then one of the number one skills or top concerns, I hear when I meet with customers is, hey, these new technologies are great, and this all sounds great, but we can't hire or train enough people to deploy and operate at scale anytime soon. This is challenging every company and is demanding the need for solutions that are easier to use and more complete in their coverage, reducing the need to integrate and manage numerous disparate systems, from a number of vendors. And finally, doing all of this at scale is incredibly difficult. The environments today are in a cloud-native environment are extremely dynamic, scaling up and down with not just hundreds of, say, virtual machines that need to be managed, but in a distributed cloud-native environment, you may have thousands or tens of thousands of interdependent services likely deployed across local data centers, multiple public clouds, and out to remote edge deployments. So this dynamic nature and vast services just really outscales the ability to manually manage the security details. So automation is a must in a cloud native environment. So how do you protect yourself in this type of environment? Really to address these challenges, you can't rely on a single security method for protecting critical processes and data. You must apply a layered security method that can be applied across a full application and infrastructure lifecycle. This is typically referred to as defense in depth, and it appears extremely complex in many situations. So this layered security strategy has multiple ways and opportunities to detect an attack or an exploit in progress, and to prevent or limit any damages which may occur, which is why it's critical to have this type of layered security approach. And as I mentioned, on the surface, this looks very complex with various tools applied at numerous points. And honestly, it isn't simple. But that shouldn't deter you from a holistic defense in depth strategy, because it's the most effective approach in today's cloud native environment. And our goal at SUSE is to make it less complex and easier to deploy and operate versus many of the alternatives. So let me walk through a few of the key layers of a defense in depth approach. Let's start with the vulnerabilities and compliance. The first concept everyone must understand today is the need for full lifecycle coverage, pipeline to production. And this should be obvious for many of the most recent high visibility exploits. And this starts with the supply chain. And the supply chain here isn't just an ISV, it isn't just the developers, but there's numerous contributors to the supply chain. Developers, ISVs, leveraging open source projects, and it all starts with the build pipelines. And beyond the build processes, images are often stored in repositories, and you need to be able to continually scan those repositories for newly discovered vulnerabilities that may be occurring. Additionally, CICS benchmarks and policy enforcement throughout the lifecycle is desired. You want to ensure that you don't inadvertently have misconfigurations in an environment, which is one of the leading causes of vulnerabilities. Isn't necessarily the vulnerability in the code itself, but in how the environment is set up and configured. And then you also want to be inspecting for secrets and open file permissions or other compliance violations that you may have in place. And then finally, the compliance analysis. Many of you are out there, maybe subject to regulatory compliance and need to prove to regulators, that you're meeting those compliance and that you've got auditors to satisfy and be able to pull those environments and reports together in a real-time fashion. The next area is about modernizing your runtime protection. I mentioned the shortcomings of legacy approaches to securing the runtime environment. And there are numerous modern technologies and techniques that can be applied to your infrastructure. First, to protect the runtime environment from pipeline-induced vulnerabilities is through admission controls. And this is essentially putting a gatekeeper at the entrance of your production environment to check deployments against your security policies prior to launching them into production. The cloud native ecosystem of Kubernetes and containers also requires new firewall capabilities. Kubernetes has a layer of network abstraction that really makes it impossible for any type of traditional network security tool to see the network traffic and to understand what's going on and finally determine if there's an attack happening. A key protection needed is a layer 7 container firewall that is specifically designed for Kubernetes and containerized environment. And this requires that you have a solution specifically designed for containers, Kubernetes, and cloud native architecture. And then finally, you want to enable real-time continuous inspection of all network traffic within Kubernetes environment, whether it's east-west, pod to pod, ingress, egress, etc. to look for any type of violation or network attacks. And so you want to make sure, that there's no unauthorized processes and file activities occurring within the containerized environment. And that leads to, and it sounds like we're kind of really getting into a common theme you're hearing across the event today, is zero trust. The historical approach to security is to identify what is not allowed and to attempt to prevent that specific set from occurring. However, this requires knowing what is bad ahead of time and continually maintaining a list. A more effective approach, and one that we enable with SUSE NeuVector, is a zero trust approach, which is to define a list of allowed behavior for your containerized environment. What are the allowed network connections, the allowed east-west, as well as ingress and egress traffic? What are the allowed process and file activities for a specific container? And everything else is untrusted and can be blocked if set to that protect mode. This is probably the most critical element in detecting and trapping attacks at day zero, or even beyond, when critical business processes need to continue to operate, even though there may be known exploits in your environment. A great example for this, and I'll go back to the one I mentioned earlier, is Log4j. It's fresh in everybody's mind. Wasn't that long ago, and when you were scrambling to determine where you had it, what critical business processes were running. Did you need to turn off specific applications for fear of the extent of exposure that it might create? And with a strong zero trust methodology in place, those typical Log4j exploits that were available would have been completely preventable in a strong zero trust environment. And then finally, I mentioned automation. How do you possibly maintain and manage security amidst thousands of developers and suppliers releasing monthly, weekly, or daily as soon as code is ready, against a backdrop of the security vulnerabilities and bad actors releasing new threats on a weekly or daily basis? You must automate, again, from pipeline to production. You must have policies that are effective at blocking the bad guys or even blocking unknown attacks. So just how do you get those policies? Manual creation is really infeasible, and it's just too slow. It reduces the developer's agility and is error prone and often too lenient. Better, again, automation is through behavioral learning. And let the system learn during development, testing, and staging. What is the normal behavior for this particular application? What files does it access? What's the pattern of that access? What type of data is transmitted? Where is it transmitted to? And then once the appropriate behavior is learned, all other behavior is deemed suspect. And then in production, the system can warn of unusual behavior or automatically block those threats that may be in place or may be occurring. The other aspect is policy as code. Learn once or code once and then deploy many. Think multiple instances of the same environment, such as an edge environment. Being able to define those policies as code and then apply them anywhere as applications are being updated, as applications are being deployed. With the application is the most effective and efficient way to do that. So those are really the key building blocks to a defense in depth strategy. And as I mentioned, this sounds extremely complex. SUSE's NeuVector brings all of these requirements into a single, easy to use solution. Vulnerability and compliance begins at build time in the software supply chain. We also check code as it's submitted and then throughout its life cycle. Once it's in the registry, whether it's internally built or if you got it from an external supplier or from an open source project, we continually scan the registry looking for newly discovered vulnerabilities. And we update our databases on a daily basis from multiple sources, trying to make sure that we've got the most up-to-date compliance information and CV information that we can possibly get. SUSE NeuVector also brings modern runtime compliance with admission controls and layer 7 container network firewall that enables deep packet inspection. So you can see exactly what is going on at any time and monitor the traffic going on between containers in the environment. And all of this is critical to setting up zero trust protections on process and file system actions. And to improve the ramp up time of staff and bringing new applications online, NeuVector incorporates a behavioral learning methodology on new processes to establish that normal baseline. And then once learned, NeuVector can be put into protect mode for either alerting on violations or put it into a hard lockdown mode, which prevents any unauthorized, behavior that wasn't previously learned in the learning phase of it. So really shuts down the exposure to those day zero violations. So to wrap this up, trusting legacy security methods is really insufficient to protect a modern enterprise. What you really may need to make sure you've got in place is a defense in depth strategy. Starts with protecting pipeline to production, and from a compliance and vulnerabilities management, and you want an integrated system from end to end, so you're not having to integrate and piecemeal it together with a variety of tools. You need a modernized runtime protection environment that understands Kubernetes and containers and can see the traffic that's going on in a modern environment and be able to scale and run anywhere across any infrastructure. And then obviously trust no one. Put in a zero trust methodology from the very beginning. And then finally automate across the spectrum of the portfolio. So that's really the summary and net of what we see as the criticality in cloud native environment and what you need to put in place. So you definitely look forward to any follow-up questions people have, or if you want to get more insight into how we accomplish what we do, feel free to reach out and we'll get you in touch with the team to help make that happen.